Hello, this is Simple Math for you, and our lesson today will be about reflections. أهلا بكم في قناتكم Simple Math for you، ودرسنا اليوم عن الانعكاس. Actually, there are four major types of transformations. في أربع أنواع من أنواع التحويل أو الانتقال أو التغيير. They are rotation الدوران، translation اللي هو الإزاحة، dilation اللي هو التكبير والتصغير، reflection اللي هو الانعكاس. وسنبدأ بالانعكاس reflections, which is the easiest, I think, and the most common in the real life. We will start by reflection. And what is reflection? When figure is reflected in a line, each point of the pre-image and its corresponding point on the image are the same distance from the line of reflection. Let's stop at this point. Let's take this shape and see, assuming that this is the top that we are going to reflect. How will this top be looking like? If you take this point and this is the line of reflection, which is similar to the mirror, اعتبر انها هي مرآة. And when you reflect, لما تعكسه, you will find that the image will be here. And if you measure this distance from here to here, it should be exactly the same as the distance from here to here. So the distance between the pre-image, الصورة قبل الانعكاس, and the image, الصورة بعد الانعكاس, to the line of the reflection, إلى محور الانعكاس, will be the same. تكون نفس الشيء. يعني لو هاي كانت 5 سنتي، هاي لازم تكون 5 سنتيمتر. Not only that, the reflection, which is the image, and the original image, the original picture, should be congruent to each other, exactly the same, copy paste. Okay, صحيح إنها مقلوبة, yes, ولكن نفسها بالضبط. حلو. So first, the distance should from the pre-image to the line of the reflection should be equal to the distance between the image and the line of reflection. Or in other words, we can say they are equidistant from the line of reflection. This happens, or this occurs, or this is valid for each point of the object, whatever the object is. But what else? Also, we can say that the line connecting the image and the pre-image is perpendicular to the line of reflection. يعني the image should not be here. It should be perpendicular, يعني متعامد على محور الانعكاس. So this is another thing you should be careful about, irrespective of where is the line of the reflection. In our lesson today, we will study how to reflect any object in the coordinate plane, across or in a vertical line, in a horizontal line, and also across y equals to x. Y equals to x. When a figure is reflected in a vertical line that is not the y-axis, the y-coordinates of the image remain the same, of course, because here, if you reflect this point over this vertical line, the image will be here. Knowing that this is perpendicular, this distance is equal to that one. And as you see here, imagine that this is x-axis, y-axis, this is y-axis, and this is x-axis. As you see here, the y will remain the same. The only change will happen in x. In the opposite way, for the horizontal line, the situation will be different, or the reverse for that. For the horizontal line, let's assume this is the horizontal line that we are going to use as line of reflection. If you take any point here, if you reflect this point, it will be somewhere here. And as you see here, the x-coordinate will stay the same, and the y-coordinate will change. Remember these points. Now, what about reflection in y equals to x? For this purpose, I'll give you this exercise. Reflection in y equals to x. We have triangle ABC, and this is the mirror line. That is y equals to x. Y equals to x, by the way, for your information, is when it is passing through 1, 1, 2, 2, 3, 3, 4, 4. This is how we graph it. Now, if you don't know the rule, what will you do? You will use the rules of reflection. You will take the first point, A, let's say. This is the pre-image. And when you want to reflect it, you should match until you have a perpendicular line. Measure this, or you can count how many diagonals you are passed by. You have 3 here. So from the other side, you have another 3. So you will reach here. This will be A prime. A prime is the image of A across dy equals to x. Let's apply the same rule for the C. We will go the perpendicular segment here, and we will count 1 unit approximately. Okay, and this will be somewhere here. You have to be careful. It should be perpendicular. As you see, it's not that easy. Also, B prime will be, you match in a perpendicular way, go to the other side, and this will be here. I'll change it. Almost here. Yes, now it's okay. This is equal to that. And this is B prime. And if you match, you will notice that this is exactly the origin. Let's match using another color. It's not matching actually properly. Let's now it's going. Yeah, this is the new triangle, and as you see, it is exactly a copy-paste of the first one. Actually, it's not easy to do this procedure when the line is slanted. إذا كان الخط مائل من الصعوبة نوعا ما أن تضمن أن يكون الرسم دقيقا في لهذه الدرجة. So what will you do? I will erase what I have done here, and I will use another approach, which is easier in my opinion. What is this approach? Let's check the coordinate of this point. A originally was what? Go to the x-axis, it is 2 paired with 8, so 2, 8. B is 2 and 5. C is 7 and 5. The reflection across y equals to x is simply, as per the rule, interchanging the x and the y coordinate. xy will be yx. So A prime reflection, A prime, so if A was 2, 8, after reflection, A prime will be 8 and 2. And I will plot the point. 8 and 2. So go to 8 up to 2. It will be here. Right? Okay, again, we have also B is what it was 2 and 5. So B prime will be 5 and 2. I'll go to 5 up to 2. And this will be B prime. C prime, C was 7 and 5. So C prime will be 5 and 7. And this will be 5 and 7. And when you match, you will have the same figure, the one that we have before, in a very accurate and nice way. So you can use this rule, especially when the line is not vertical. If it is y equals to x, just interchange. Remember, this is exclusively for y equals to x. If it is y equals to x, just interchange. Let's check this example. If you want to reflect across a horizontal or vertical line, these are solved examples. Now, if you have a shape like STVR or STV, you want to reflect it in the line y equals to -1. So what will you do? My advice is to draw the line y equals to -1. So go, this is -2, this is -1. Y equals -1 is a horizontal line passing through y equals to -1. So it is passing through the -1. And then find the distance between this point and this line of reflection. This was at 1, this was at -1. So this distance is 2. Repeat it again. It will be exactly here. So this will be your image. And you would repeat the procedure for every other point. Let's take, for example, T. The distance from T to this line should be, for example, 4 units. So from this -1, you go down 4 units. The same distance will be going down 4 units, and you will reach here. Okay, so 4, I mean +1, 5, yani 5, and here 5, because here 4 until the x-axis, then another one. So 5 units, and the distance between the line of reflection and the image should be the same, which is 5. So you can count and you can easily plot each point and then match the figure. Okay, here the same thing. When we want to reflect across the line x equals to -2, I will draw the line x equals to -2, and I will do it in an easy way. The distance between S and this line of reflection is 2, so the distance between S prime and line of reflection should be 2. Same thing, I will put for the T. For the T, let's change the color. From T to the line of reflection, how many units you have? You have how many squares? Count. It is 1, 2, 3.5. So from the other side, 1, 2, 3.5. So this will be your T prime, which is the image, الصورة. إذا عد المسافات. المسافة بين محور الانعكاس والنقطة الأصلية يجب أن تكون مساوية للمسافة بين الصورة ومحور الانعكاس من الجهة المقابلة. وهكذا تكمل كل النقاط ثم تصل بينها. Now we will reach to the conclusion that these are the points that you will have after reflection. Just copy them. Now we have some rules that might help in this. يعني في عندنا بعض الرولز اللي تساعدك انك you can find it without even drawing this line. What are these rules? If you want to reflect a point or any object across the x-axis, reflection across x-axis, what happens? If it was 3, 2, then it will be 3 minus 2. Remember, x coordinate will stay the same. Y coordinate will just reverse the sign. This is only for reflection across x-axis. Let's take an example. If you want to reflect this point, let's say S, across the x-axis. S originally was 2, 4. If you want to reflect it across x-axis using the traditional way, count the number of units here. It's 4 units from 4 to the x-axis. So you will go 4 units down until you reach the -4, right? And this point will be 2 and -4. As you see, x coordinate did not change, while y coordinate just reversed. You can conclude that by just sketching, no need to memorize even. For the y-axis, only x coordinate will reverse. Across y equals to x, we mentioned that through the example of the triangle, you just interchange the coordinate. If y equals -x, y equals -x will not be like that one, positive slope. It will have negative slope like that one. So this will be y equals -x. And what happened here is just not reversing or not interchanging. You interchange and then reverse the sign. So it will be 2, 3, and then reverse the sign as well. So everything will be reversed. Now, the problem is that when you have to reflect across x equals to a number, like the ones that we have here, x equals -2, y equals -1. If you don't want to sketch, what will happen? Let's say we have here an example. Triangle BCD has coordinates mentioned here. Select the coordinates of the vertices of the image after reflection in line x equals to 3. Now, if you don't know a rule, then you will draw a line x equals to 3. This is x equals to 3. Vertical line passing through 3. And then, as usual, count from C to this line of reflection 2 units. So from the other side, this will be my C prime. Where is C prime? 1, 2, 3, 4, 5. And the Y 1, 2, 3, 4. So 5 and 4. So this is my C prime. D, let's go to D. D, count 1, 2, 3, 4, 5 units to the axis, then 5 units from the other side. 1, 2, 3, 4, 5. So where do you expect B to be, B prime to be? If this is 3, 4, 5, 6, 7, 8, 9, you will count actually. So B prime, sorry, D is D. D would be until 8. Sorry, I just miscounted again. Okay, again here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 4, 5, 6, 7, and you can add it till it will reach to 8. So this will be 8 and minus 4 actually. And 8 and minus 4. You can try and you can check. You can do that. Of course, if the graph paper is full, it's easier for you. But what if I want to apply the rule mentioned above here? What can I do? Actually, simply you can multiply 2 by 3, which is 6. Since you are reflecting across a vertical line, which is x equals to a number, then x will change, y stay the same. So originally, all these y's will stay the same. So you will choose where the y's stay the same. Where do they stay the same? So for B, y should be 3, like this one, B prime, or this one. So we have A or C are choices. For example, also here, 4 and 4. Here we have -4 and -4. These stayed the same. Original is the same as the image. Now, what about the x, which is changing? After you multiply the 3 by 2, it will be 6. Then what will you do? You will subtract the original 6 minus 3. So we have 6 minus 3, 9. So I will obtain the B prime. Let's check with the C. 6 minus 1, 5. And this is what we have. 6 minus 2, 8. So this is the correct answer. So when you have a constant here, what will you do? Multiply by the constant by 2, subtract the original x or y depending on the axis given to you. Now, what about this question? Thomas is designing a sculpture garden for an art museum. There is a sidewalk connecting the center of this is the sidewalk he is talking about, museum entrance to the edge of the lawn. As you see here, this is exactly like y equals to x. Thomas has a set of 4 points يعني in a series that he wants to be equidistant على مسافات متساوية from this sidewalk على مسافات متساوية من هذا المحور اللي هو sidewalk. He plotted positions for Q and X on the graph. هاي البوزيشنز موجودة. Let's check the position. This position is 1 paired with 3. So 1 with 3. And this X is 2 paired with 4. Okay, very good. Now, if pieces Q and R are a pair, Q and R are a pair, and X and Y are a pair, where will the pieces R, Y be placed in the garden? So we have here a pair that includes this point and its reflection. So if you do it manually, it will be here. And this point is 3, 1. You should expect that. We reverse the X and the Y. Similarly, for the other point, if you do it manually, this will be the perpendicular distance and count 1 unit from the other side. It will be here. And this point will be 4 and 2. 4 and 2. Opposite to this is 1. So it is 4 and 2, and it will be interchanging X and Y. So this X is paired, he said, Q is paired with R, and X is paired with Y. So the pairs that we are looking for are those. Let's continue. Now we have practice. Graph the image of each figure under the given reflections. Determine the coordinates of the image. We have here line equal x minus 1. If you don't want to use rules, then draw y equals equals -1, vertical line, and count 1, 2. From the other side, 1, 2. So this will be E prime. Mirror, مرآة. From F to the axis, count 1, 2, 3, 4. From the other side, 1, 2, 3, 4. So exactly here, F prime. I will erase those so that you don't disturb. So this is E prime, and I will match. This is x equals -1. Okay. So هي أول واحد. I will leave it عشان تتذكر. So this is E prime, F prime. Okay. What about D? 1 unit from the right, so I'll be 1 unit to the left. If you count G, 1, 2, 3, 4, 5. From the other side, 1, 2, 3, 4, 5. So we need to add 1 square here. And on the same line, perpendicular to that reflection line of reflection, then I will match. And this will be my figure. Okay. If you want to apply the rule, what will happen? As I told you, since you are reflecting across x equals -1, so you will keep all the y's the same. Let's assume here we have f originally. Where is f? 1, 2, 3. So it's 1 and 3. So f prime will be what? We will keep the 3. We will play with the x. So 2 times -1 is -2. -2 minus 1 -3. F prime should be at -3, 3, which is correct. This one, -3, 3. Okay. And you can actually 2 minus 1 minus 2 minus 2. We're talking about F. Sorry. Yes, we have done a mistake here. We are talking about E and we are talking about something else. Let's again. What was F? This is F. I'm talking about this one. F. F is 1, 2, 3 with 1, 2, 3. Now reflection about that one. So 2 times -1 is -2. -2 minus 3 is -5. So will be -5 and 3. Go to F prime, it's at -5 and 3. الأول لخبطنا بين ال F وال E. They look at the same. Again, let's see E. E is 1 and 3. Reflection will keep the Y since we are reflecting using X. Multiply -2, then -2 minus 1 is -3. So we mix the F and the E. Now it's -3, 3, صح? G originally was at 4 and 1, 2, 3 at -3. Reflection will lead to G prime. G prime will be exactly the same position of Y multiplied by 2 minus 2 with 4 minus 2 minus 4 is -6. So -6 and -3, and that will be our position, -6 and -3, etc. You can continue and check for D as well the same way. If you don't want to use the rule, we have done it without the rule. For the y equals to x, as I told you, I prefer to use the rule. I will find out the coordinate of each point. S is at 2 and 1, 2, 3, 4. S prime will be just interchanging. R was at -2 and 3. So R prime is 3 and -2. T was at 2 and -3. So T prime is -3 and 2. U was at -2 and -4. So U prime is just interchanging. Let's plot the new points. S prime 4, 2. So go to 4, 2. So this is S prime. R prime 3 minus 2. T prime -3 and 2. U prime -4 and -2. -4 with -2 u prime. Then match. You see, it's congruent to the original shape. مطابق للشكل الأصلي بس معكوس عبر x y equals to x. Y equals to x, for your information, is this one. Y equals to x. Again, this is y equals to x. يعني this is the mirror. كأن هاي الميرور. You can flip it. You can يعني make it vertical like that so that you can imagine in a good way. Okay, here square KLMN in the line y equals to -2. As I told you, you can simply draw y equals -2. This is y equals to -2. This is y equals -2. Horizontal line. And then you can use the traditional way, counting 1, 2 units from here. So K prime will be there. L will be 3 units from here to here. So 3 units from here to here. So this is L. Not the axis, 3, 4, 5. So 1, 2, 3, 4, 5. So it will be somewhere here. This is L prime. N, 1, 2, 3 to the axis. So we'll count 1, 2, 3 other side. So this will be your N prime. M will be 1, 2, 3, 4, 5, 6. From the other side, I count 1, 2, 3, 4, 5, 6. And actually, you should have a square as well. يعني the final shape should be a square congruent to the original square. It looks perfect. Not bad. Okay. This is how we deal with that one. If you want to use the rule, then use the coordinate way. يعني for example, let's check the M since it is very far. M originally was where 1 paired with 1, 2, 3, 4. Since we are reflecting across y equals -2, so y will change, x will stay the same. Multiply by 2, it will be -4. Then -4, -4, -8. يعني you subtract the result minus the original. Result minus the original. So it will be -8. And that's why we have here far at 1 and -8 approximately. Let's reflect this same square, but across x-axis. Across x-axis means this is the line of reflection, and the first point K will stay the same. Any point on the line of reflection will be located on itself. Now, we will do the same thing. From here to here, this is the line of reflection. From the other side should be here. So this will be N prime. Count also here. This will be 4. From the other side will be 4. So this will be your M prime. L to the x-axis 3. So the L prime will be there, L prime. And then you will match the new points. Okay, it looks pretty here. Good. Now, what will you notice here? Originally, M was at 1 and where 4. صح? Where was M prime? M prime was at 1 and -4. And the reflection was across x-axis. What happened? X stays the same and Y just reverse the sign. And it will be valid for all points. Referring to the rules here that I was telling you about, look, if you reflect across x-axis, x-axis means x stays the same, reverse the y, just change the sign. For the y-axis, you will change the sign of the x-coordinate. So you can also use the coordinate way if you don't want to count. If you don't want to count the units, just find the new points, then plot them. Determine the coordinates of S -7 and 1 after reflection in the line y equals to 3. You have the choice. Either you remember or you just imagine where is the point, where is y equals to 3, plot the point minus 7 and 1, and then reflect it, or use the rule. And I prefer to use the rule in this case. Since y equals to 3, means what? Y equals to 3 means y will change, x will be the same. So multiply by 2. 2 times 3 is 6. And then 6 minus 1, it's 5. Minus 1, which is this one. That's it. You can plot and check at the same time. Let's see the other point, which is this one. Yalla, think little bit. Determine the coordinates of the point 6 minus 4 after reflection of x when x equals to 2. What will happen? X equals to 2. So the change here, x equals 2 means y. X equals to 2 means x will change, y will stay the same. Multiply 2 by 2 is 4. Then 4 minus the 6 is negative 2. Now let's see this question. The image of A, negative 1 and 1. Negative 1 and 1. This is A. Negative 1 and 1. Is negative 1 and negative 3. So this will be negative 1 and negative 3. This is the image, negative 1 and negative 3. Which reflection produces this image? يعني at what line? Actually, you can imagine here that there is a line at the middle, midway between these 2 points, where the distance here is equal, and this is a horizontal line. So that means here we can directly guess that the line is y equals to minus 1. This is one approach. What is the other approach? We can realize that this line is the midpoint between the 1 and the negative 3. So we can find simply the midpoint by adding 1 plus negative 3 and divide by 2, which is negative 2 over 2, which is negative 1. And this is also the same result. What other approach? We can use the rule that we have before. Since x is not changing, so it is reflected across y equals to something, across a horizontal line. So we should expect y equal to something. How can we find the y? You remember that we name it as b. So we say that 2b minus the number, which is y, the original y, يعني, equals the new y. So what will you do? 2b minus original y is 1 equals the new y is negative 3. So you can take this to the other side. 2b is negative 2, divide by 2 minus 1. So y equals minus 1. You can use either approach you like to find the same result. Let's see here, a point in the second quadrant with coordinate minus AB is reflected across y equals negative x. Remember, y equals negative x, we are reversing everything. We are reversing first step, interchanging x and y, then reverse the sign. So it will be minus v and a. Last question here. Is the image of a point reflected in a line sometimes, always, or never located in the other side of line reflection? In most of the cases, if the point was here, the reflection was other side. If it was here and you want to reflect here, it will be the reflection to the other side. But there is one case only when it is exactly on the line of reflection, and we discussed that before. Remember when we here reflected across x-axis, this point was on the line x-axis itself. So the image was on itself. And this is the special case. That's why we cannot say here never, because it is true always, except when the point is on the line. So we say sometimes when, except yani, it's always true, except when the point is on the line of reflection. يعني في كل الأحوال دائما الانعكاس بيكون للجهة المقابلة، ما عدا في حالة واحدة فقط عندما تكون النقطة على نفس محور الانعكاس، فتكون الانعكاس هي نفس النقطة. إذا راجعنا اليوم أو درسنا مبدأ الانعكاس، وكما ترون أنه سهل يعني للغاية ويحتاج بس قليل من التدريب. شكرا جزيلا لحسن استماعكم. Thank you very much and see you in the next video. إلى اللقاء. Now let's see this question. The image of A, -1 and 1, -1 and 1, this is A, -1 and 1, is -1 and -3. So this will be -1 and -3. This is the image, -1 and -3. Which reflection produces this image? يعني at what line? Actually, you can imagine here that there is a line at the middle, midway between these 2 points, where the distance here is equal, and this is a horizontal line. So that means here we can directly guess that the line is y equals to -1. This is one approach. What is the other approach? We can realize that this line is the midpoint between the 1 and the -3. So we can find simply the midpoint by adding 1 plus -3 and divide by 2, which is -2 over 2, which is -1. And this is also the same result. What other approach? We can use the rule that we have before. Since x is not changing, so it is reflected across y equals to something, across a horizontal line. So we should expect y equal to something. How can we find the y? You remember that we name it as b. So we say that 2b minus the number, which is y, the original y, يعني, equals the new y. So what will you do? 2b minus original y is 1 equals the new y is -3. So you can take this to the other side. 2b is -2, divide by 2 minus 1. So y equals -1. You can use either approach you like to find the same result. Let's see here, a point in the second quadrant with coordinate -ab is reflected across y equals -x. Remember, y equals -x, we are reversing everything. We are reversing first step, interchanging x and y, then reverse the sign. So it will be -v and a. Last question here. Is the image of a point reflected in a line sometimes, always, or never located in the other side of line reflection? In most of the cases, if the point was here, the reflection was other side. If it was here and you want to reflect here, it will be the reflection to the other side. But there is one case only when it is exactly on the line of reflection, and we discussed that before. Remember when we here reflected across x-axis, this point was on the line x-axis itself. So the image was on itself, and this is the special case. That's why we cannot say here never, because it is true always, except when the point is on the line. So we say sometimes when, except يعني, it's always true, except when the point is on the line of reflection. يعني في كل الأحوال دائما الانعكاس بيكون للجهة المقابلة، ما عدا في حالة واحدة فقط عندما تكون النقطة على نفس محور الانعكاس، فتكون الانعكاس هي نفس النقطة. إذا راجعنا اليوم أو درسنا مبدأ الانعكاس، وكما ترون أنه سهل يعني للغاية ويحتاج بس قليل من التدريب. شكرا جزيلا لحسن استماعكم. Thank you very much and see you in the next video. إلى اللقاء.